Welcome to Day 6 of DailyAIWizard, your journey to mastering AI. I'm Anastasia, your AI guide, here to make learning AI simple and fun for everyone. Today, we're taking a deep dive into unsupervised learning, another key concept in machine learning. We'll explore how it works, its types, applications, and more, with a demo to bring it all to life. Let's explore this exciting topic together and see how unsupervised learning uncovers hidden patterns. Today, we'll cover everything you need to know about unsupervised learning. We'll define what it is, break down how it works with a detailed process, and explore its two main types, clustering and association. We'll also look at real-world applications, challenges, and a demo to see it in action. This lesson will help you understand how unsupervised learning finds hidden patterns in data. Let's uncover those patterns together and get started. Unsupervised learning is a type of machine learning that uses unlabeled data to discover patterns. Unlike supervised learning, there are no correct outputs or labels provided to guide the model. Instead, the model finds patterns or groups in the data on its own without any supervision. For example, it might group customers by their buying habits to understand their preferences. It's like exploring a new place without a map, discovering hidden structures as you go. The unsupervised learning process follows three main steps, different from supervised learning. First, we collect unlabeled data to analyze. Then, we apply an algorithm to find patterns, like grouping similar items. Finally, we interpret the results, such as identifying clusters of data points. It's a process of discovery, where the model uncovers hidden structures on its own. Let's break down each step to see how this exploration works in practice. Unsupervised learning has two main types, clustering and association. Clustering focuses on grouping similar data points together, like organizing items into categories. Association is about finding relationships between items, such as products often bought together. Each type uncovers different patterns in the data, depending on the task at hand. Let's explore both types in detail to understand how they work and what they reveal. Clustering is a type of unsupervised learning that groups similar data points into clusters. It doesn't use predefined labels, so the model decides how to group the data based on similarities. For example, it might segment customers by their behavior, like grouping frequent shoppers together. Clustering finds natural groupings in the data without any prior guidance. It's like sorting a pile of objects into similar categories without knowing what they are. Association is the other type of unsupervised learning, focusing on finding relationships between items. For example, it might identify items often bought together, like bread and butter in a grocery store. There are no labels involved, just patterns of co-occurrence that the model discovers. Association is useful for discovering rules, such as if this, then that, in the data. It's like finding connections between things without being told what to look for. Unsupervised learning relies on algorithms, which are the rules the model uses to find patterns in data. These algorithms are used in both clustering and association tasks, depending on the goal. Examples include k-means for clustering and a priori for association, which we'll explore next. The choice of algorithm depends on the task and the type of data we're working with. Let's look at a few popular algorithms to see how they uncover hidden patterns. Unsupervised learning powers many real-world applications across industries. Customer segmentation in marketing groups, people for targeted campaigns, like identifying luxury buyers. Anomaly detection, such as fraud detection in banking, spots unusual patterns like suspicious transactions. Recommendation systems, like Netflix suggesting shows, use unsupervised learning to find similar content. It uncovers valuable insights in fields from business to entertainment. It's amazing to see how it helps us understand data in new ways. Unsupervised learning has its challenges. Since there are no labels, it's hard to evaluate if the results are correct or meaningful. The patterns found, like clusters, can sometimes be difficult to interpret without context. Choosing the right algorithm and parameters, like the number of clusters in k-means, is also tricky. Often, human expertise is needed to make sense of the outputs. These challenges highlight the importance of careful analysis in unsupervised learning. That's it for day 6, everyone. Thank you for joining me on this AI journey. I'm Anastasia, and I hope you enjoyed learning about unsupervised learning. If you found this lesson helpful, please give it a thumbs up, subscribe, and hit the bell for daily lessons. Tomorrow, we'll explore reinforcement learning explained, the next step in our ML journey.